Next one will be how to make a data product for Gaia-X, and I hope I pronounce the first name right. It will be Jesus, CTO digital unit from Tecnalia, and I think you're also on the board of Gaia-X in Spain? Yeah. Perfect, wow. Red button, green button, and one microphone, unless you want to speak in stereo. But,
Okay. So for me, it's a pleasure to be here to share with you some of our experience and initiatives related to Gaia-X. Okay, have made my presentation. I'm Jesus Santamaria from Tecnalia, the CTO of the digital unit, and also the responsible of the technology working group in the Spanish hub of Gaia-X. Okay, this morning my colleague Alberto has talked about the GIS market, that economy, and the usage of Boot-X as an example. Now I will talk about a totally different area, that is how to make a data product for Gaia-X, so how to make a data product Gaia-X compliant. It's important to keep in mind the definition of the data product as a collection of one or more data that should be packaged and made ready for exchange by a data producer. So first of all, some context about the pitch, about the presentation. This is part of work in the OASIS Horizon Europe project. OASIS, Open Autonomous Programmable Cloud Apps and Smart Edge Sensors, is a project in the area and the destination of data of Horizon Europe that is dealing in creating a new programmability framework for edge devices with two main aspects, focusing on decentralized intelligence based on advanced analytics and using also a schema of federated identity for the devices. And the idea is to provide this framework as an open source at the end of the project. So first, some of facts and figures of the project. This is a 3 years project that will run until 2025. So we are more or less in the middle of the project. It's a 8 million project that is composed by a consortium of 21 partners from 9 different European countries. So in the project, we are working on different use cases, in 6 different use cases in different domains. You have there also the URL of the project if you want to see more details about the project. So the consortium covers a wide range of different kinds of organization. We are, as Tecnalia, we have several research centers, but there are also Democritus, our SEA, is Fraunhofer, is also IMEC, and there are also companies like Engineering, Capgemini, and others, and also some university like NCUA from Athens. Okay, so related with the use cases, all the project and all the use cases are running around the concept of decentralized intelligence and smart swarm of edge devices. And we have one use case related with health, that is working in the analysis of voice for the Parkinson, related to the Parkinson disease. There's a second use case that is in the area of electromobility. So that is related to the battery recharge of electrical vehicles for the optimal operation of the grid. There are a couple of use cases that are more related with inspection. One is focusing on the using of a drone swarm for the inspection of high-mast infrastructure, and a second one that is more focusing in the area of structural safety of infrastructure, so in the area of construction. The fifth use case is related with industry, with collaborative robotic automation. And finally, the use case where we are working is related with wind energy and is related for the predictive maintenance of wind turbines. So one of the interesting aspects of the pitch or of the work that we are doing is that we are focusing in a real-world business case. So we are defining a data product, but taking into account a real-world business case that is provided by Capgemini Spain, and because they are working in a solution that processing the acoustic emission of the blades of the wind turbines, they are trying to improve the operation of the wind turbines by predicting failures and also predict or foreseeing which should be the best maintenance operation that could be done to improve the work in the wind farm. So should we keep in mind that the maintenance cost of the wind farm are very high, and there is a need for optimize both the operation and the maintenance work in these wind farms. So usually we have a network of sensors that are monitoring the condition of the blades in a wind farm. And the idea is that this network of IoT devices could cooperate, could exchange information, could collaborate with the cloud level to exchange information. And in this way, we have, in the one hand, the wind farm owners that could provide this acoustic data from the specific farms that they have. And in the other hand, we have the maintenance companies that could gather all this information, could provide advanced analytics on this information, could provide these acoustic emission signals, and could work on this advanced anomaly detection service for the wind farms. So the data product is a kind of optimizes blade acoustic monitoring swarm system. So for this process of the data product definition, we are using a tool that is the data product canvas. That is a similar approaches have been used by or proposed by the Data Space Support Center, and the idea is how we can go from data sources, from the data gathering, to define the data that provide or add values, provide value to the customers, which are the added value that we can look in the data that could provide this value for the customers. So in this schema, we can see from left to right all the aspects related of analyzing the data in order to identify this data product, and from the right to the left, we can see the customer perspective and how could be the benefits and the pains and gains. So in defining the data product, the questions that should be answered, what we need to work about is, first, what are the data sources that we need to create value to the customers? So in this case, we have the wind turbine acoustic monitoring systems with the different information that is gathered, the raw acoustic data, but we have also additional data like the historical data related with the blade failures or with the period of stops of the wind turbines, and also which are the current wind turbine blade maintenance plan. After analyzing these data sources that we have, the next step is to analyze which kind of data transformation should be done, how we can create value from those data, which is the advanced analytics that we got apply for the data, in order to define which are the most valuable data that we can include in the data product. In the other side, we need to take into account which should be the customer benefits, which are the specific key indicators that should be managed, and also which are the constraints, the problems, the challenges that we need to to produce this value for the client. So finally, for this in this case, the data product will be different set of data. For instance, the technical reports that will be based on this advanced analytic once the acoustic information has been processed, and this will be the form of a report that could be shared with the different clients to improve the maintenance plan of the wind farms. There could be also other data included in the data product, like the predicted anomaly detection or the improved or the dynamic maintenance operation that should be included in the plan, or even in some cases to anonymize the data that some users are needed to do in this way. So about how we have done the application of this data product in the use case. How in this extract of the full architecture of the system, but related with this data product deployment, the main aspect that we have used, we have selected to use the IPFS, the Interplanetary File System, as a distributed repository to store the data product information. We will have a set of edge devices that are collecting the data what will be needed to generate this data product. We will have also the cloud advanced analytics to process the data and to generate the final information that will be included in the data product. And finally, in the right part, we have selected as part of the project to offer this data product using the Gaia-X rules, and in order to test the capability of exchange this data in a Gaia-X ecosystem, and we have selected to use Eclipse Data Space Connector for the data change. Okay, this slide summarizes which is the main steps in the process of make this data product available and to make this data product Gaia-X compliant. The first step is to generate the data, to generate the data product and to store the data in the repository. The second step is the part that is more related with the Gaia-X compliant mechanism, that is how to register these data products, how to use in the data space ecosystem, but also how this could be open to a Gaia-X ecosystem and to be used by any participant from a Gaia-X ecosystem. And in the third step, once that this has been built, is the demonstration of how to consume this data, that we have both possibilities. We have developed a demo user, a mockup, where from the Oasis portal we can claim and play the role of a data consumer and to establish a contract with the data provider and make the exchange of the data. But this the same mechanism is open for an external consumer that can use the same EDC connector and also ask for the data and consume the data. Okay, so we will see very briefly these three steps. First, a few in this video, we'll see how we start generating the technical report, that is the data product, how it will be generated, and how it will be stored in the repository. So this is the tool that Capgemini has provided, how they analyze the data, while select the data that will be included in the report, an example of how the report is prepared and with the different diagrams and information once the information is processed. Then the next step is to store the data product in the repository. We have an API of the IPFS system to generate the directory where store the data. We can upload specific data products in this repository. We can make a selection of which are the different data products that are already stored in the repository in order to select one of them. So this is one example of this API that is related with this part of the process. So we have selected the report that we want to store, and we claim to the operation, upload the report in the repository. So, and finally, we can make the directory list and see that, the data product has been successfully uploaded and is already there. Okay, next step will be we can also to check, as we have made a kind of directory of all available data products in the repository. We can select the one of the option of the API to show which are the different data products that are stored. We can select by data product ID. We can select by path, and to check which are the different data products that are related to this data product ID. So, and we can visualize which are the specific data products, the specific, in this case, the specific files that are already stored in the repository. Okay, next, the second step, that is the part related with the registering the data products in the Gaia-X ecosystem. This is the part related with generating the verifier credential. And also with, okay, we need to have a certificate to generate also the ID, to generate the 3 credentials associated with the participant, to be included in one clearinghouse. For this checks, we have used the Gaia-X Lab version 1 clearinghouse to make the test. And there is an example or the steps to generate the verifiable credential and to store the data product in the repository. Finally, we have the message that the data product has been created in the SES services, and that and with an URL that will be the one that could be used for consume the data. And finally, the final step is the data product consumption. So in this case, we have here the catalog of the Oasis portal, where all the different data products that are uploaded in this catalog. We have also the one related with the data acoustic monitoring system, but also other data products generated by other use cases. And as I mentioned, we can play the role of data consumer. We can see the attributes of the data product. We can see there the description, the owner, but also the required attributes, the URL and the asset ID that will be needed to ask for this data product from outside the repository. We can see which are the contract agreements that are already established. There is no contract agreements, and we can generate a contract agreement directly from the portal. So in this case, we are requesting the contract negotiation with the repository, and once we get the contract agreement identifier, it will be uploaded in the list, and we will see that has been created. We have the identifier, the signing date, and a button is created to make the data transfer and to ask for the data product for the technical report that we have previously uploaded to the repository. So we can ask for the transfer. We are requiring which are the data with the attributes that we need to perform the data transfer. We have the endpoint and the authorization information needed to ask to the Eclipse Data Space connector to ask for the file, and we have also the screen in the portal to ask to the Eclipse Data Space connector for this specific asset. We are receiving the data, and this can process it and store it as a zip file that will contain the technical report that we have previously uploaded in the repository. So this is the technical report. We have gathered the technical report, and now we can use it, check it, and so on. So this is a summary of those, which are the steps that we have performed in this case, to first create the data product and then to make it available in a Gaia-X ecosystem, and to close the loop with the data transfer. Okay, this is all for me. Thank you very much.
I think we have some time. Any questions, anybody? No?